Hey everyone, we all know what our cars look like from the outside, right? But have you ever stopped to think about the incredible, totally hidden tech that makes them go, think, and, well, even see? Today we're going to pop the hood, figuratively speaking, and explore the secret tech that's powering almost every modern car on the road. Okay, let's get into it. So, let's start with a big question. What is really inside that machine sitting in your driveway? And I don't just mean the engine, the seats, and the steering wheel. Nah, we're going way deeper than that, into the amazing components that make up this complex, interconnected system. The easiest way to think about it is to imagine your car as a kind of living thing. Seriously, it's got a powerful mechanical heart, a super fast digital brain, and a whole network of senses. And in this explainer, we're going to break down all three. So let's start with the heart. This is where all the power comes from. And right at its core, you'll find these high-pressure fuel systems that are honestly just incredible feats of engineering. I want you to look at this number for a second. 2,000 bar. That figure is almost impossible to wrap your head around, but that is the typical pressure inside a modern high-pressure diesel fuel system. It's just immense. So, what does 2,000 bar actually feel like? Well, picture the crushing weight of the water at the very bottom of the deep ocean. That is literally the kind of pressure happening inside your car's fuel rail, thousands of times a minute. This insane pressure turns diesel fuel into this ultrafine mist, which means you get a much cleaner, way more powerful burn. It's a huge reason cars can meet today's super strict emissions rules. Now, to handle that kind of pressure day in and day out for hundreds of thousands of miles, the parts have to be perfect. And I mean perfect. We're talking about manufacturing with micron tolerance. A micron is 1/1,000,000th of a meter. To put that in perspective, that's about 70 times smaller than the width of a single human hair. It's just mind-bogglingly precise. And get this isn't some small boutique operation. This happens on a massive industrial scale. We're talking about factories that can pump out over 1 million of these incredibly complex fuel injection sets every single year. It takes a symphony of more than 1,400 advanced machines doing everything from laser welding to precision grinding just to build the heart of your car. Okay, so you've got this amazingly powerful mechanical heart, but what's controlling it? What's telling it what to do? Well, that's the job of the car's digital brain. Every single modern car has an electronic control unit, or ECU for short. This is the onboard computer. It's the central processor, making thousands of calculations every single second, managing everything from your engine's timing to the emission systems. It's basically the conductor for the entire mechanical orchestra. And this brain isn't a one-size-fits-all kind of deal. Nope. There's a whole family of these ECUs, each one tailored for different jobs, from smaller units for little city cars, all the way up to these heavy-duty platforms for massive trucks. The most advanced ones can even handle things like natural gas or hybrid systems, and they let engineers tweak over 4,000 different settings to get everything just right. But here's the most important question, right? How can you possibly trust this little computer with your safety? Well, the answer is a foundation of incredibly strict international standards. You've got things like ISO 26262 for safety and AUTOSAR for software design that make sure these systems are unbelievably reliable and secure. And then they're validated with hundreds of thousands, even millions of kilometers of real-world road testing. Of course, a brain is pretty useless if it doesn't have any information. It needs a nervous system to tell it what's going on. And in a car, that's where the huge network of sensors comes into play. And when I say a network, I mean it. There are dozens and dozens of sensors monitoring literally everything. The exact position of the engine's crankshaft, the temperature of the transmission fluid, the speed of each individual wheel for your anti-lock brakes, even your AC has its own sensors. It is a constant, massive river of data flowing to the ECU at all times. And some of these sensors are way more sophisticated than you'd think. Take the advanced oxygen sensors, sometimes called lambda sensors. Mastering how to make these with high accuracy is a massive technological achievement. In fact, it's something only a handful of companies in the entire world can actually do, and it's absolutely critical for controlling emissions. But if you have sensors for everything, things can get really complicated, really fast. So how do engineers deal with that? With some pretty brilliant innovations. A perfect example is tire pressure monitoring systems, or TPMS. Instead of making hundreds of different sensors for every car model out there, They developed one single, programmable sensor that can cover 98% of all vehicles on the road. Now that's smart. Okay, so we've got the heart, the brain, and the nervous system. What happens when you put all of that together and then give the car the ability to not just sense itself, but to sense the world around it? Well, that's when we get to the dawn of true vehicle intelligence. So how does a car actually see the road? It's not with just one kind of eye. It actually uses a combination of different technologies that work together to build a complete picture of what's going on. The car basically has two types of sight that are perfect complements to each other. You've got 77 gigahertz radar, which is like its long-range vision. It can see far down the road, and it cuts right through rain and fog to measure distance and speed with pinpoint accuracy. But then you have the camera, which gives the car something radar can't: context. The camera understands what it's looking at. It can recognize another car, a person, or a traffic sign. It's that combination of seeing and understanding that creates real intelligence. And this all happens in a constant, four-step loop, over and over again. First, the sensors sense the world around them. Second, the brain fuses all that data from the radar and the camera into one cohesive picture. Third, it decides if there's any danger or if an action is needed. And finally, it can act, either by flashing a warning to the driver or even by helping with the braking or steering. And the result? It's a whole suite of safety and convenience features that you probably use every single day. Things like adaptive cruise control that automatically keeps a safe distance, blind spot detection, lane departure warnings. They're all direct results of this fusion of sensors and intelligence. Even cool features like 360-degree parking cameras or using your phone as a key are part of this whole evolution. So where is all this going? What happens when you keep making the heart, the brain, and the senses better and better, and make them work together even more seamlessly? Well, that's when you start building the actual future of mobility. This quote really just sums it all up perfectly. The mission is twofold. You have to keep perfecting the high-quality, super reliable parts that are the foundation of today's cars, while at the same time, you're pushing the boundaries of innovation for the next generation of smart, connected, and electric vehicles. Think about the journey we've just seen. We went from a single mechanical fuel injector machined to a precision 70 times smaller than a human hair, all the way to a connected supercomputer on wheels that can see and react to the world around it. The evolution is just staggering. So it really only leaves one question: what on earth will your car be able to do next?